Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. Hello, Lesson 2, Finding Systems of Inequalities that Describe Triangular and Rectangular Regions. Okay, so here we go. Classwork opening exercise. This is review. You've done this before. Pause the video, see if you can do this, and we'll see if you did it correctly. Okay, so it says graph each system of inequalities, and is the point 1, 2 a solution? In other words, is it in that region that makes both true? So if I were to graph these, y is greater than or equal to 1. Let's see. Let's see, x is less than or equal to 5. So if I go 1, 2, 3, 4, 5 and call this 5 right here, if that's the x value 5, and this is y equals 1 right here, then y is greater than or equal to, the equal signs tell us our lines are going to be solid for starters. So let me choose blue. Actually, let's do this, blue, and lines go on forever both directions and not too thick. All right, so the first thing you do is just graph the line y equals 1. And that is a horizontal line at 1, just like that. That is y, so this is this. Y is greater than or equal to 1. Oh, this is the equate equals. I haven't done the greater than yet. X is less than or equal to 5. Focus on the equals first. X equals 5. I'll do that in red. So x equals 5 is the vertical line at 5. So there is x equals 5. So if we are greater than 1, we're above. And if we're less than 5, we're to the left. So I want to be above and to the left. So it is this region up here. And I will just use a rectangle to shade it in. So it would go to the lines like this. And then let me just adjust this to, let's see, line color none, and fill line color, I don't know, purple. Whoops, none, purple over here. And then let me go to properties and fill effect. I want to see through it. So there we go. All right. So there is the solution to my system. It is all the values greater than y equals 1, all the values of y greater than 1, and all the values of x less than 5. Is the point 1, 2 a solution? Well, here's the origin. Over 1 up 2 is right here. And that is the point 1, 2. Is it in the shaded region? Yes. So is it a solution? Yes. Okay, so yes, 1, 2 is inside that region. So part 2 says, is 1, 1 a solution? Okay, so 1, 1 is a point which is right here. Okay, I am less than 5. I'm not greater than 1, but I'm equal to 1. So it says greater than or equal. So the answer to that is also yes. Okay, so yes, 1, 1 is on the border of the region and included in the region. So it's left of 5 and on 1. Since there's an equal sign, then the answer is yes. All right, number 3. The region is the intersection of how many half planes? Explain how you know. Okay, so it is the intersection of 2 half planes. X is less than or equal to 5, and y is greater than or equal to 1. X is less than or equal to 5, splits the plane in half at a vertical line, x equals 5, that's that red line, and to the left. Y is greater than or equal to 1, cuts the plane in half horizontally from the line y equals 1 and above. All right, part B. Here's another one. Same situation. So here we go. Okay, just give myself some room here. Y is less than 2x plus 1. Okay, so that's a linear equation. mx plus b, remember that? Y is less than 2x plus 1. 1 is the y-intercept, so that'd be right here, and a slope of 2, which means goes rise 2, run 1, rise 2, run 1, down 2, left 1, and so on. So you can very quickly just graph this line like so. It is not an equal sign, so I want a dashed line. So I'm going to choose my line. I'm going to choose a line. I'm going to make it blue. I'm going to make it thinner, and I'm going to make it dashed because it does not include the points on. Okay, so there is my line, y less than 2x plus 1. So it's dashed, and we're going to shade below. Okay, and now we're going to do y is greater than or equal to, it's equal, so it's going to be a solid line. Y-intercept of -2, which is right here. You always plot the b first, and the slope of -3, which means go down 1, 2, 3, and over 1, or up 1, 2, 3, left 1, up 1, 2, 3, left 1. So there is my line. Choose a line, choose red, and this one is going to be solid because there was an equal sign. All righty, so I'm going to just start here, drag it like so. Let me just fix this. Just trying to get this very accurate. Okay, so there are my two lines. One solid, one is dashed. All right, so we want to be below the blue line, and greater than means to be above the red line. So below blue and above red is this area over here to the right. So let me shade that. Okay, so here's the shaded region. I couldn't get it to go all the way over with this program, but you understand that it's going to continue here. All the shaded region is to the right of the blue and to the right of the red. So above the red, below the blue. Okay, so is the point -2, 1, 2, positive 1, 2, 3, 4, right there in the solution set? And the answer is no. It satisfies the second equation, but it does not satisfy the first. Okay, so you say no, it does not belong to that overlapping shaded region. Is the point 1, 3 in the solution set? So I go over 1 and up 1, 2, 3. And I'm on the border of this blue dashed line. And since it's dashed, it's not equal. It says less than. So 1, 3 is not less than. If I substitute in 1 in the blue equation or inequality, then I'd say 3 is less than 2 times 1 plus 1. 3 is not less than 3. It does not make it true. So the answer to that is also no. So I would say, no, 1, 3 is not in the solution set because it is on the boundary, but that boundary is not included because it's not equal. Okay, so there's the first two. Okay, page 2, part 3 says the region is the intersection of how many half planes, and explain how you know. So they're still talking about this one here. So this red line splits the plane in half. There's a half on the left and a half on the right, or a half above and a half below, depending how you're looking at it. And the blue dash line splits it into 2 parts. So what's the answer to this part? It is the intersection of 2 half planes and includes the portion of the line y is less than 2x plus 1 above the intersection, and the portion of the line y is greater than or equal to -3x minus 2 below the intersection. Okay, example 1. Here is a rectangle. One corner is at the point 1, 2, and the opposite corner is over at 15, 7. Okay, so in talking about this diagram here, there's a few things that we can talk about. If this were a region, what would be in the solution set? Well, any x value, and since the lines are solid, then I guess that being on the edge would be considered in the rectangle. Then any values of x between, so x could be between and including 1 and go all the way up to this X value over here, which is 15. So if I chose any X value, 1, 2, 3, 4, 5, decimals, 3.8, it doesn't matter. Anything between 1 and 15, including the ends, then we would be on this line here, anywhere in the plane to infinity and negative infinity. But then we need to restrict our range. Our Y values are 2 and 7. So Y would have to be less than or equal to 7, but greater than or equal to 2. So if I have any situation here, so if I just wanted to choose a point that I would say is in this region, pick a value of for X between 1 and 15, and just randomly I choose 7, and choose a value between 7 and 2. And if I say, well, 4 is between 2 and 7, so I'll put a 4 there, then the point 7 comma 4 should be here. So that would mean go over, if this is 1, 2, 3, 4, 5, 6, 7 would be somewhere around here, and up 4, here's 2, 4 would be somewhere around here, just for an example. So any point in this region, we're restricting domains and range, okay? And that's, I think, all I'm going to say about that diagram. So let's move on to exercises 1 through 3. And it says, given the region shown to the right, name 3 points in the interior of the region. Okay, so I'm just going to make this really simple. I'm just going to pick 3 points. There's one there. It's the point 4, comma 3, 4, comma 3. So I'm just picking random points. There's a point, and that is the point 4, comma 15. So there's infinitely many solutions here, because if I chose this point here, then that is, say, 4.5, comma 9.5. So I can choose non-integer answers. I can choose rational answers here. And then it says, B says to name 3 points on the boundary. Well, I could choose this bottom corner, and that's the point 3, 2. So this is just a quick exercise here. I can name the top right corner, which is here, and that is the point 5, comma 20. It does not have to be a corner. I could pick any point on the edge like this, and that is the point 5, comma 12. So I can choose any point on 3 as long as it's 2 or more, but not more than 20. And I can choose any point on this horizontal line where Y is 2, as long as X is between 3 and 6, or 5, I'm sorry, 3 and 5. And then again at the top here, if my X is between 3 and 5, then my Y equals 20, then I'd be choosing points on this edge. So C says to describe the coordinates of the points in the region. Okay. Okay, so to answer that, we would say all X coordinates are greater than or equal to 3 and less than or equal to 5, and all Y coordinates are greater than or equal to 2 and less than or equal to 20. And that's kind of like I was saying up here using the notation. Page 3, part D says, write the inequality describing the X value. So I did that on the prior problem, so we're just doing the same thing. So I would want an inequality with X here, and they're solid sides, they aren't dashed, so we're going to use the equal signs. So it's X is between 2 values, and X is here, and we're in between 3 and 5. So we aren't going more than 5, so X is less than or equal to 5, but X is greater than or equal to 3. Now it says to write the inequality describing the Y values. Well, Y is between 2 things, just like the X was. My lowest Y value is here, and my highest Y value is here. So it is greater than or equal to 2, but less than or equal to 20. Write this as a system of inequalities. Okay, so what you would do here is use set builder notation. So you'd say the set of all X's and Y's such that, and then we would just list these, such that X is between 3 and 5, and Y, I put a 3 here, just a moment, let me fix that. This is not a 3, it's a Y. No, it's not. It's an X. Oh, struggling here. All right, X is between 3 and 5, and Y is between 2 and 20. So it's the set of all X, Y such that X is between 3 and 5 and Y is between 2 and 20. G says, will the line X equals 4 and Y equal 1 pass through the region? So if I drew a line X equals 4, and let's do it in, let's do this thickness, and how about red? And X equals 4 is going to be a line right on the X equals 4, like so. And the Y equals 1 is going to be right here. Let me just move that up a little bit. Like so. So X equals 4 obviously passed right through the center, and Y equals 1 did not pass through the region. And it says draw them, and there they are. So X equals 4 went through right here, and Y equals 1 was below. Number 2 says, give the region that continues unbounded to the right as shown to the right. So this arrow here is saying that this area is continuing this way forever and ever and ever. All right. Name 3 points in this region. Well, if I pick this point right here, that's the point 1, 3. I could pick a point, I don't know, 1, 2, 3, 4, 5, 1, 2, 3, 4, the point 5, 4. And then I can get really crazy. As long as I'm between 1 and 2, 3, 4, 5, 6, as long as I am in between there, if my X value is between 1 and 6, so how about 2, and this is going to the right forever, I could have a really big number, like 1,000,000. So go over, oh, I got that backwards. I'm sorry. My Y would be between 1 and 6. So I'd have to put a 2. And then if I had 1,000,000 over here. Okay, let me just use this comma as X, Y, so you're not confusing with the commas in the million. So if I went to the right 1,000,000, I'm way off the screen to the right here, and I go up 2, I would be in this region that continues forever to the right. It says to describe in words the points in the region. Okay, the region is above Y equals 1 and below Y equals 5. It starts at X equals 0 and continues to the right without bound, is how you would say that. Or it continues to the right forever. C says, write the symbol of inequalities that describes the region. Okay, so it's the same as the prior one. So I need my X to be between 2 things. So X is between, and I don't see any lines here, so I'm not going to use equal signs. And it does say the region is above Y equals 1. It's not including Y equals 1. So X is between, so X is going this way. This is my X axis. X is greater than 0, but then it's less than positive infinity. So in other words, well, it's going from 0 to infinity, it goes on forever. And we don't normally write that. We would just do this. X is greater than 0, or 0 is less than X. So I could rewrite that as X is greater than 0. I guess that'd be a better way. Okay, and then if we're talking about Y, that would be a between inequality. There's no equal signs because there's no lines, and Y has to be less than 6 but greater than 1. D says to name a horizontal line that passes through the region. So if I just take a line and draw it horizontally through the region like so, there's a line horizontal through the region, then I would say that equation is Y equals whatever number value that is, and that is 4. So that'd be the equation Y equals 4. If I moved it up to 5, it'd be Y equals 5. If I moved it up to 4.5, it'd be Y equals 4.5, etc., etc. Okay, page 4 brings us to number 3, and it says, given the region that continues down without bound as shown to the right, so here's a region, it goes down forever and ever and ever. Describe the region in words. So I would say that x would be between -2 and 3, and y is less than 0. But let's put that into words. Okay, so the region is to the right of x equals -2 and to the left of x equals 3. It starts at y equals 0 and continues down without bounds, or continues down to infinity. B says to write the system of inequalities that describes the region. So talking about x, this x value here is -2, and this value here is 3. There are no boundaries, there's no lines. So it's an inequality where x is between -2 and 3. As far as y goes, this y value is 0. So y is less than 0. Y is negative. So anything between -2 and 3 that is below 0 on the y, and it goes forever and ever. C says to name a vertical line that passes through the region. So if I choose a line and I just drop the line right there, and that is at 1, then I would say that is the equation y, just kidding, x equals 1. So it's any vertical line would be x equals some value, and it's got to be between -2 and 3. So no matter where you put that line, if you put it over here, it'd be x equals -1. If you put it here, it'd be x equals 2. If you put it on the axis, if it was the y axis, it'd be x equals 0. All right, example 2 says to draw the triangular region in the plane given by the triangle with a vertice of 0, 0. So I'll put a dot at 0, 0. It's right there. That is 0, 0. The point 1, 3 over 1 up 1, 2, 3 is right there. That would be the point 1, comma 3. And then the point 2, comma 1 is over 2 up 1, which is right here. That is 2, comma 1. I would connect it with a segment. Let's make it thin and blue. And so you would use a ruler to do this, of course. And I used the wrong line. It's got an arrow. Let me just do a segment. That's thin and blue. Starting here, going to there, starting there, going down to there, and then I let go of it. So let me fix it. Okay, so there it is. There's the triangle. Can we write a set of inequalities that describes this region? And the answer is yes. We have 3 lines. We know the slope. I didn't close my parentheses here. We know the slopes by figuring out the equation of the line. So this line right here is, so I'll call this line here the point. You need to find the slope, and slope is change in y over change in x. So 3 minus 0 over 1 minus 0 equals 3 over, 1 minus 0, 3 over 1, which is 3. My slope is 3, but I'm going through the origin. So my equation of that line is y equals 3x. Okay. And how about I change the colors of these so that we know what I'm talking about when I'm labeling them. So that's the black line. And then I'll use red for this one. And the red one I will change right now. It'll be this one. It's the easier one of the two to do. That's going to be red. And so I have 2 points, and one is the origin. So for the red one, I would say the slope equals my 2 points, y2 minus y1 would be 1 minus 0, divided by x2 minus x1, which is 2 minus 0. So my slope on this one is 1/2. It's going through the origin, so my y-intercept is 0. So my equation is y equals 1/2 x. And then finally, if I do the blue one here, this one's a little different. I have to use the point slope formula because it's up to left 1, up to left 1. If it continued, it would go there. So I can use the graph on this, and I will. So the y-intercept is 1, 2, 3, 4, 5. That is the point 5 right there. So if this line continued, it would hit the y-axis at 5. So I know my b is 5. I just need to find my slope, which is y2, either one you want to use, 1 minus 3, over 2 minus 1, which equals negative 2 over 1, which is negative 2. My y-intercept would be 5 because it would continue up 2 over 1 here. So my y equation is y equals 2x plus 5. So my three equations are y equals 2x plus 5, y equals 1/2 x, and y equals 3x. Those are the three lines, and they're color-coded. And those would be the set of inequalities. So I would have to be, now I'm going to change this inequality to answer the question. I'm going to get rid of my equal signs now. I found linear equations. Okay, but if these are solid lines, okay, so I'm going to, it didn't say that they were not including the edges, so I'm going to change my inequality. That's still going to be equal, but is it less than or greater than? So the black line, we are to the right of it or below it, so that would be less than 3x. In the red one, we're going to be on the edge of it, which would be the equal sign, but is it greater than or less than? We are above the red line, so that's greater than. And then finally, the y equals negative 2x plus 5, or below or to the left is less than. So these are our three inequalities right here. Okay, page 5, exercise 4 and 5. So pause the video, see if you can do these, and come back and let's check. Alrighty, so here we go. Given the triangular region shown, wait, where am I? Oh, there I am. Given the triangle region shown, right here, triangular region shown, describe this region with a system of inequalities. Okay, let's color code these for starters, and I will do the same thing with colors. So if I choose a segment from here to here, and let's make that something other than that color. How about red? Okay, and then I draw another segment and we'll make it blue from here to here. And then finally one that is, oh, I don't know, green. I'll use green, I guess. How about this green? So there are the three lines that I need to write equations for a system of inequalities. All right, so let's do the red one first. In red, that is a vertical line. So when it's vertical, it is x equals. So that is the line x equals 0, but we're to the right of it. So we want to be x greater than or equal to 0. So that puts us in the first and fourth quadrant. So we've just cut out these two, and we now know we're only going to the right. But then we need to restrict our range in the upward direction using the blue line segment. And in order to do so, I need points. Well, this is the point 1, 2, 3, 4. This is the point 0, 4. And this point over here is 1, 2, 3, 4, 5, 6. That is the point 6, 0. Okay, so if I want to know what the slope of this line is, then I say m equals the change in y, which is 0 minus 4, over the change in x, which is 6 minus 0. That will give me a negative 4 over 6, or a negative 2/3. The y-intercept is 4, so my equation is going to be y, and it's below, is less than or equal to, because it's a solid line, so we're below or equal. Y is less than or equal to my slope, negative 2/3 x, plus my y-intercept is 4. So the equation negative 2/3 x plus 4 is this line segment here. We want to shade below. Finally, I have above. So we are dealing with range here. So it's y. We want it greater than or equal to because of this solid line. And we want this point here as well to calculate our slope. And that is negative 1, 2, 3, 4. That is over 0, down 4. So when I do my slope here, it's going to be 0 minus a negative 4 is plus 4 over 6 minus 0, which equals 4 over 6, or 2/3. So my slope is 2/3 x and my y-intercept is -4. So these are the three restrictions on our domain and range. There is the system of inequalities that makes this shaded triangle. Okay, number 5. We're given this trapezoid. They gave us the points, the vertices, and we wanted a system of inequalities again. So I'm going to do the same thing. I'm going to choose a segment. We'll start with red, and we'll just work our way around like so. And then I'll switch to green, and that is going to be this segment on this side. And then I'll switch to blue, and that will be this. And finally, purple will be this side. Okay, so we have 4 equations in this system. So let's start with the red, and that is a horizontal line. So that is going to be x is equal to, but we're below. So below is less than or equal to. X is less than or equal to, is it x? No, it's y. My apologies. Let me fix that. We're dealing with range restriction. Y is less than or equal to 4. That's the red line. The green line, we have to find slope. And we're given this point 1, 4, and we're given the point 2, 0. So my slope is going to be y2 minus y1 over x2 minus x1. So my slope is -4 over 1, or simply -4. Okay, so now I need to know my y-intercept. Well, this is up 4 over 1. So I'd have to go up 4 more, and then I'd be at a half. And these are half increments, by the way. So my slope is -4. So I went down 4 over 1. Notice that that's a half and that's 1. So for everyone, we're going over 4. Well, we went from 2 to 4. Going from 2 to 1, we went up 4. So from 1 to 0, we're going to go up 4 more, and that would be a y-intercept of 8. Okay, so this is a restriction on the range again. So it's y, and we're below it. So it's less than or equal to. And it's going to be the equation -4x plus 8. Okay. Alrighty, so moving along, the blue line. The blue is a horizontal. That is going to be a restriction on the range again. And we are going to, this time, we want to be above. So it's greater than or equal to, and this is the line, the x-axis, or y is greater than or equal to 0. And then finally, this line here in purple, we want to know what the slope is. Well, it's up 4 over 1. So it's positive 4. So just to save time, it is this, but we're going up 4 over 1. I use the graph this time. The slope is 4, and we are below this time. So less than or equal to 4x. And again, we're going to meet up here at 8. If we go up 4 over 1 again, it would be 8. So those are the 4 systems. That's the system of inequalities that would shade in this region. Okay, page 6 brings us to the end of lesson 2. Go to your problem set.